Today I want to have a look at a tube amplifier. So what we have here is a single-ended triode amplifier. It's very simple. It's only a power amplifier. It consists of, we got 3 tubes here, rectifier, the output tube, and driver tube. So this is a 6 SL7, it's a dual triode. Then we have a single 300B and rectifier. We got 2 transformers. One is the output transformer and the other is the power transformer. A couple of the big capacitors here for filtering. And it's got 2 taps. You can probably not see these over here. It's got one for 8 ohm speakers and one for 4 ohm speakers. And we got a couple of switches, on-off switch and standby switch. All in all, very simple design. It's of course a little bit ridiculous amplifier design. Not that tubes are ridiculous, but considering that this thing will actually consume something like 80 watts from the mains, and it will only deliver maybe 5, 6, 7, maximum 8 watts, I would say, but probably realistically more like 5 watts. So this amplifier has got a couple of minor problems. The first problem is the tube socket over here. It's not very good. I bought these, I have 2 of them. This is just a mono, so need one more for stereo. But the tube socket over here is not very good. It gets a little bit scratchy and you have to move around the tube to get a good connection. I tried cleaning it, but it hasn't really helped much, so I wanted to change the tube socket. And I want to have a look inside. I think there are a couple of things we need to make a couple of small changes, but we'll get back to that later. Let me just remove the tubes and we'll try flip it around and we can have a look inside. There we go. Careful, it don't fall on the floor. Yeah. And see if I can flip it around. It's pretty heavy. Just a quick side view of it here, and here we go. So just need to get these screws out and we should be able to get inside. Okay, screws out, and we can just flip over here. So this little warning is very true about tube amplifiers. So we can expect about 400 volts DC circuitry in here. So basically, if it's switched in or if the capacitors are charged, it's not safe to pretty much touch anything. So, just going to do a quick test here on the capacitors, just to make sure they're discharged. They should be by now, but let's just make sure. Yeah. So looking inside the amplifier, we can see, so we got the mains input here, so it goes directly to the power transformer under here. So actually the power switch is on the secondary side. It doesn't switch the mains directly. Anyway, after the transformer, some of the windings goes over to the rectifier tube, and then it will come back here to the first filter capacitor, runs to a choke here, and then the second filter capacitor. So it's probably our B plus supply over here somewhere. There's probably a resistor on it. First thing I want to do is have a look at replacing this tube socket over here. Of course, it's the one with the most things soldered onto it. So what I want to do is just get a couple of pictures. I'm just going to use my old phone for that. Let's see if I get a couple of good pictures. Just need a few different angles here. Okay, I think that should be fine. Just in case something goes wrong, but I don't remember where wire was attached. But I will try to solder in the new socket at the same time as I remove connections from here. I will just try to solder them over one at a time. Well, of course, some of the resistors here you see connected multiple places, so it's nice to have a couple of pictures for reference. So another thing is the rectifier tube is, don't know if you can see it here, see if we can get this to focus. So it's a 5V4GA, and it is not designed to drive capacitors as large as used in this amplifier directly. So I need to have a look at that. I think what I will do is to use a thermistor on the input. So basically what will happen then is the voltage will start meeting high resistance. I think I got some 120 ohm thermistors. So it will start at a lower voltage, and then as the thermistor heats up, the internal resistance will get lower and lower and lower until I think it's below half an ohm. And then you will have full voltage on the circuit. So it will be a little bit nicer on the tube. I mean, it turns on fine, and it doesn't look like, well, I don't know, but I don't think this tube has been replaced, but it's too hard on the tube the way it's designed here. So I want to change that. And while we're looking at the large capacitors here, so we're going to have something like 400 volts across these terminals here, or capacitor. I really want some bleeding resistors. I haven't been able to find any. I don't see any bleeding resistors here. So I think I got some 1 mega ohm resistors, 3 watts, something like that. At least that will make it a little bit safer, and the capacitors will discharge a lot faster than they do now. Okay, so I've moved the camera a bit, and I found a tube socket to replace. Let's not forget the clamping ring. So the first thing I want to do is just take the screws out of the original tube socket. See if I can, without losing anything. There we go. So I'm probably just going to speed this up a bit because it's going to take some time to desolder and resolder everything here. Okay, so that is the tube socket replaced. Just been checking it, it looks all good, but I'm just gonna change the camera first. Okay, I changed the camera back. So I got some 1 mega ohm 3 watt resistors here. See if we can get that to focus. Yeah, you see. So actually I think it's gonna be enough with just one, because we only have this choke between the two capacitors, and I think just one lead resistor between these two traces here should be fine. So I'm just gonna form one, and then we'll get it soldered in here. Okay. See how that fits. Yeah, that looks good. I'm just gonna shorten these a little bit. A little bit extra solder here, solder. A little bit on the resistor, just to make things easy. Okay. Yeah, that looks good. And well, it's high voltage, so we have to make sure these are not, the leads are not close to any other traces. But this should be good, so at least the capacitors will discharge a little bit faster. Then I have a thermistor here. You see that? So this is 120 ohm at turn on, and then it's going to fall down to about half an ohm within a number of seconds. So I'm just going to put that in series here and make sure it's not touching anything, because it's gonna get pretty hot. So let me just do that. Let's see if I can get wire off. Hot. I think I'm just gonna cut that. Doesn't matter, it's a little bit shorter. Okay. Just gonna bend it around, so even if the sort of fails, it's still not going to fall out. It's a little bit tricky. Okay. Solder that in there. Probably change to a bigger tip, but this will do. Get some on the end here, clean that tip. I think it's oxidized a little bit. It's coming now. Hot. Just gonna form this a little bit to wrap around the wire. Okay, I think that would do. Cut the end off. Okay, I think that's pretty good and pretty safe. Because we have to remember, well, this means voltage we got here. So I could test the capacitors, but this amplifier is not that old. I don't know, maybe 15-20 years. I don't expect any of the capacitors to have any issues. So that should be it for repairing and updating. So I think this video is long enough, but I will make another video where we test it out, and I want to do a bias adjustment. I believe it's probably this potentiometer here. So I hope you enjoyed that, and we'll continue next time.